Good morning, chemistry. Mr. McKee here, and I want to go over some background for today's lab activity. So if you would all turn to page 37, please. That's a blank page. And I would like you to take some notes as I go over this information, if you would be so kind. So the first thing I want to talk about is the difference between evaporation and boiling, because in this lab, we're going to be working primarily with evaporation. But it is very similar to boiling. We've talked about boiling before, so let's review. Boiling occurs when IMAFs, that is these attractive forces between molecules in their liquid form, are overcome. So if you apply enough heat, you can break these attractive forces, and then the liquid molecules are able to escape into the air as gas. They're no longer attracted to each other. And depending upon the strength of the IMAFs, that's what's going to determine the boiling point. So stronger IMAFs equal higher boiling point, as we have discussed before. Very similar with evaporation. First of all, what is evaporation? It's similar to boiling, except that it only, as you can see in the diagram here, occurs at the surface of the liquid. This happens at a lower temperature. Room temperature is enough to make evaporation happen. And depending upon the strength of the IMAFs, that's going to affect how much evaporation you have, just like with boiling. So, stronger IMAFs equal less evaporation, which is to say it's going to take more energy to get liquids with strong IMAFs to evaporate. And that's kind of the focal point of today's labs. We're going to look at 6 different liquids: acetone, hexane, heptane, ethanol, and butanol. Hopefully you've made some predictions about which ones of these liquids are going to have the strongest IMAFs. So a little more background here on evaporation. Evaporation causes cooling, as our picture says here. That's the basis of sweat. That's why humans and other animals sweat, in order to cool off and absorb the energy of the heat that we create through our various biological processes. So surface molecules absorb heat. These are the surface molecules down here. And that increases the kinetic energy. They move up, they move faster, like we saw recently with the animation that we looked at in class. And eventually, they're moving so fast that it can overcome the force of attraction, which is, again, IMAFs, those forces between molecules. And eventually, they're going to escape out into gas or water vapor form. So the stronger the IMAFs, the more heat the liquid is going to absorb, and so the less cooling you're going to have. So that's kind of the basis of today's lab. We're going to be measuring how much a liquid is able to cool something, and we're going to be comparing different liquids. In a sense, you could think of this as comparing different kinds of sweat to decide which sweat is going to be the most effective. So that is our background for today's lab.